Yeah, good morning everyone. Good morning. Yeah, so I think in the last class 35, question number 39 we left out. Question number 39 we left out. Yeah, can you go to the 39 and let's start this. Question number 39. Please go and solve it. Actually, class is scheduled at 6 o'clock. Now I started around 8 because very less people because of it's maybe cold or whatever it may be, right? Very less people are there, so that is the reason I postponed it. But anyhow, so yeah, those people who missed out live, they can see the recording also, right? Let's start now. Question number 39. Hi Preeti. Yeah, can you go ahead? This problem we are not done in the last class. Check what is the answer. Consider the binary relation. Some binary relation is given. S is equal to xy, where y is equal to x plus 1. X comma y belongs to 0 to 0, 1, 2 and so on. Yeah, to make it simple, let us assume that it is the 0, 1, 2 only. If you can do for 0, 1, 2, you can do for other things also. Let us assume that 0, 1, 2 only. Let us assume that 0, 1, 2 only. Yeah, go ahead. Yeah, good morning Jay. Good morning everyone. Yeah, can you concentrate on this? Consider the binary relation. Some binary relation is given. S is equal to x comma y, where y is equal to x plus 1. X comma y belongs to 0, 1, 2. The reflexive transitive closure of S is. Faisal. Yeah, good morning Faisal. Yeah, go ahead, solve this problem. So if you take x comma y belong to 0, 1, 2, x comma y belong to 0, 1, 2, right? So belong to 0, 1, 2. So let me ask you one thing. What is the S? So let me write now. What is the S? First of all, let me write S. S is equal to right, x comma y, where y is equal to x plus 1. Suppose if you take x as 0, y is 1. If you take x as 1, y is 2. If you take x as 2, y is 3. But right, let us assume that only 0, 1, 2, 3 not available, so you can close it. S is equal to 0 comma 1, 1 comma 2. X0 means y1, x1 means y2. So S is confirmed now. Now what you do is, what is the reflexive transitive closure? Can you help me now? Reflexive closure of this one. Let me write now. Reflexive closure of S is equal to. Everyone listen. Reflexive closure of S is equal to, right? It is the first of all S. Reflexive closure of any relation is first of all that relation you write. Reflexive closure of any relation is nothing but, first of all you should write it as it is, you write. Okay, I written. After writing, what are the minimal things I have to add so that it will become reflexive relation? I think first of all it should be there. Whatever relation you have, reflexive closure of that relation is first of all itself. Next one, what are the minimum things I have to add so that it will become reflexive? So what is the answer? I think I have to add 0, 0. I have to add 1, 1. I have to add 2, 2. Then only it will become reflexive. So the minimal reflexive relation including S, the minimal reflexive relation including S is known as reflexive closure. Is known as reflexive closure. So reflexive closure of S I calculated. In the similar way, transitive closure of S also let me calculate. Transitive closure of S is equal to first of all S itself. Transitive closure of S is equal to first of all S itself. Okay. Next one, what are the minimum things I have to add so that it will become transitive relation? What are the minimum things I have to add to this one so that it will become transitive relation? So let's see 0 1 starting with 1, anyone? Yes, 0 1 1 2 1 1 cancel, so 0 2 required. 0 1 1 2 1 1 cancel, so 0 2. Next one, 1 2 starting with 2, no one. So this is the transitive closure. Is asking both reflexive closure plus transitive closure of S is equal to, so I think same, all you have to write 0 1 1 2. To make it transitive, 0 2 required. Closure, right, reflexive closure, 0 0 required, 1 1 required, 2 2 required. Just to do both and do this. Because of you written combinedly, maybe if anything missing, please you take care. 0 1 1 1, I think same. 1 1 1 1 1 2 1 2 1. I think everything is perfect. So I think this is the answer for this. Please check. So I think what is the answer? Let me check now. What is the answer? I think a reflexive transitive closure of given relation S is equal to this one. If you observe clearly, equal people also required. Equal people also required. I think if you observe clearly options, right? Y will be greater than X. Y will be less than X. Y never be less than X. Y is less than or equal to X, right? See, first of all, given relation should be there, right? So it cannot be. And one more thing is, right, Y will be greater because of reflection also, equal also possible. I think B is the answer. Y will be greater as usual because it should be S first. First of all, it should be S, and equality also allowed. So Y greater than or equal to X is the better option. Right? Please verify. Actually will ask only reflexive closure. Actually will ask only transitive closure. But he asked combinedly. Do combinedly. If you can do for 0 1 2, you can do 0 1 2 3 4 5 also. If you can do 0 1 2, you can do 0 1 2 and so on also. So that there is an unnecessary part I eliminated. If anyone having any small doubt, please let me know. I will help you. If you have small doubt also, please let me know. I will help you. Sir, I have this doubt, sir. You ask me, I will help you. Check, anyone having any doubt, please let me know. Can we move to next? Boss, how many revisions are must before GATE exam? At least required revisions. Do as many as possible. There is no condition like minimum how many, maximum how many. It's not like that. As much time as possible. But give importance to all the subjects. All the subjects you take care. You take care about all the subjects as much as possible. More practice, more advantage, because you can try more right, different kinds of problems. If you try only few, right, few models only you can cover. If you try more models you can cover, because in exam you cannot do new model. In exam you cannot do new model. More, right, more practice if you do, more models you can do, so that right, more advantage you will get. Okay, fine. Let's move to the next problem. 39. In the last class we skipped it. Now I think 40 we done in the last class. What is the answer for 40? Question number 39 we skipped it, so I done it. Question number 40, what is the answer? Question number 40, the binary relation S is equal to pi. Pi is what? I think we done in the last class. Transitive and symmetric. Empty set, transitive. Symmetric also. If xy there, then only yx. If xy not there, where is the yx? So it is a symmetric and transitive both. So D, we done it already. Yeah, 41 also we done. In the 41 problem in the last few minutes we done the 41. 41, anyone having problem, please check. In the last few minutes we done this. If you have doubt, I will explain again. In the last class 41 we done. If anyone having any doubt, please go through it. Yeah, if anyone want this one explanation again, I will do. If you don't want, I can move to the next one. If anyone say this explanation required. Preeti and J, if you have any doubt, let me know. So J saying that not required. So Preeti, do you have any doubt? Faisal, do you have any doubt? Faisal Bhaiya said only good morning. Faisal Bhaiya said only good morning. Faisal Bhaiya, do you have any doubt? Gaming with soccer. So how can you keep the name like this? How can you keep the name like this? I am unable to pronounce your name also. How can you keep the name like this? You are saying good morning. I have to say good morning your name also. What kind of name it is? Gaming with Ajay, gaming with Vijay. That is perfect. What kind of name? Arey Jay, say to him little bit man. Fine. Change the name. What kind of name it is? We are there in society. Keep the nice name. Yeah, can you help me? What is the answer for this? See the answer. If anyone having small doubt, in the last class, I think a network issue also came. I will explain within 1 minute. So that we can move to the next problem. So that we can move to the next one. So let's see this one. R1 is a relation from A to B. R1 is a relation from A to B. Can you say what is the relation? Can you see? R1 is a relation from A to B. A is 1357, B is 2468. And one more. In the R1, how elements are related? If and only if x plus y is divisible by 3. If and only if x plus y is divisible by 3. X plus y divisible by 3. So I think let's try with 1. 1 and all the people try. x plus y is divisible by 3. So 1 plus 2, yes, divisible by 3. 1 plus 4, 5, no. 1 plus 6, 7, no. 1 plus 8, yes, divisible by 3. Next one, let's try with the 3. 3 to 2, 5, no. 3 to 4, 7, no. 3 to 6, yes, 9. Next one, 3 to 8, 11, no. 3 over. Go to the 5. 5 to 2, 7, no. 5 plus 4, 9, yes. Next one, 5 plus 6, 11, no. 5 plus 8, 13, no. 5 also over. 7. 7 plus 2, 9, yes. 7 plus 4, 11, no. 7 plus 6, 13, no. 7 plus 8, 15, yes. So that is R1. I hope everyone is fine with R1. Let's go to R2 also. R2 means B to C. R2 is B to C. R2 is B to C. Right, see, R2 is B to C. Let's start 2 and 1. And remember, condition for the R2 is B to C. Right, if and only if x plus y is even but not divisible by 3. Even but not divisible by 3. Let's start 2, 1. 2, 1 even, no. 2, 2 even. 2, 2 even, yes. And one more thing is not divisible by 3. 2, 2 means 4, yes. Next one. 2, 3, 5 not even. 2, 4, 6 even but divisible by 3. So don't take. So 2 over. Go to the 4. 4, 1 even, no. 4, 2 even, yes. Divisible by 3, yes. Don't write. 4, 3, 7, no. 4, 4, 8. Divisible by 3, no. 4, 4 also fine. Next one. Go to the 6. 6, 1 even, no. 6, 2 even, yes. 6, 2, 8. Divisible by 3, no. 6, 2. Next one. 6, 3, 9. Divisible by 3. So even number, no. Next one. 6, 4, 10. Divisible by 3, no. 6, 4. Even divisible by 3, no. Next one. 6 also over. Go to the 8. 8, 1, 9. 8, 2, 10. Divisible by 3, no. Even but not divisible by 3. 6, 8, 2 also over. 8, 3, 11, no. 8, 4, 12. Divisible by 3, yes. Check if anyone having small doubt also. R1 I done, R2 I done. R1 I done, R2 I done. Anything wrong, let me know. So all the R2 people are even people, sum is even, not divisible by 3. 2, 2, 4 even. 4, 4, 8 even. 6, 2, 8 even. 6, 4, 10 even. 8, 2, 10 even. Not divisible by 3. Perfect. Now he is saying that composite relation, not function. Composite relation A to C. If you want composite relation A to C, first you have to start from A. If you want composite relation A to C, you have to start from A. You have to N to C. I think starting from A means R1 is starting from A. So you have to start with R1. Then R2. So remember it's R2 R1. R2 R1 will goes to A to C. Because first right, inner one will start. So R1 is A to B. R2 is B to C. So I think B cancel. So AC will come. Right? Right. First R1 you start. R1 to R2. First R1, next to R2. Please careful. Right. So he is asking what is the composite relation, right, from A to C. A to C means R2 R1. A to C means R2 R1. Right. Please be careful. R2 R1. Inside is R1. Inside is R1. First A you have to start, right? First you have to start A, right? Inside is R1. So by seeing this one, don't confuse. Because if you do this one, right? If you do R1 R2, you don't get, right? You could have written properly. You want to say that A to C. He is thinking that you know what is the meaning of A to C. So you have to start with A means R1. Next one R2. So A to C. Let's start A to C. First go to R1. In the R1, can I help you now? In the R1, In the R1, be careful everyone. In the R1, I am trying this. In the R1, see this one, 1, 2. In the R1, 1, 2. In the R1, if at all 1, 2. In the R1, if at all 1, 2. Starting with 2, anyone? Yes, this. R1, 1, 2. Starting with 2, anyone? So the 2, 2 cancel. So 1, 2. So here 1, 2 required. Next one, R1 is 1, 2, starting with 2, anyone except first person, anyone? No. So this work is done. Let's go for 1, 8. Right, 1, 8, 1, 8, starting with 8, anyone? Yes, this. 1, 8, 8, 2, 8, 8 cancel. So 1, 2, already there. Already there. So 1, 8, starting with 8, only one person, we done it. Next one, 3, 6, 3, 6, starting with 6, anyone? 3, 6, starting with 6, anyone? Yes. 3, 6, 6, 2, 6, 6 cancel. So 3, 2. 3, 6, starting with 6, anyone? 6, 4 also. 6, 6 cancel. So 3, 4. 3, 4. Yeah, I think 3, 6 also done. Next one, 5, 4. Starting with 4, anyone? Yes, 5, 4, 4, 4. 4, 4 cancel. So 5, 4. Starting with 4, how many people? Only one person. We done it. Next one, 7, 2. Starting with 2, anyone? Only one person. 7, 2, 2, 2 cancel. So 7, 2. Next one, 7, 8. Starting with 8, anyone? Yes. 7, 8, 8, 2. 8, 8 cancel. So 7, 2 already there. I think A to C is this. 1, 2, 2, 3, 2, 2, 3, 2, 4, 5, 2, 4, 7, 2, 2. I think answer is C. Am I right? Check. 1, 2, 2, 3, 2, 2, 3, 2, 4, 5, 4, 7, 2. Is it okay? Any small mistake I done? Please let me know. Inner one will start first. Inner one will start first. R1, right? You want A to C. A to C means R1 you have to start. Followed by R2. Can we move to next? This is a nice problem, please take care. This is a nice problem, please take care. Yeah, let's move to next. Let's move to next. See, 1, 2, 1, 2, 2, 2. 2, 2 cancel. So 1, 2. Next one, 1, 8. In the R1, 1, 8. In the R2, starting with 8, 8, 2. 1, 8. In the R2, starting with 8, 8, 2. 8, 8 cancel. So 1, 2. Next one. In the R1, 3, 6. In the R2, starting with 6, 6, 2. 6, 6 cancel. So 3, 2. 3, 2. 3, 6. In the R2, starting with 6, 6, 4 also. 6, 6 cancel. So 3, 4. 3, 4. So like that we done. Nothing there. Like that we done. Like this we done. Someone is saying, why can't we take 1, 8, 8, 2, 1, 2? Where is 1, 8? Preeti said yes, she got. Okay, let's move to the next problem. I think 39 we are already done. Yeah. Can you go to 42? What is the answer of this? 42. Please try. So the reason why I kept early morning is, early morning brain will work well. So that we all will wake up early. That is the reason I kept. But because of it, the initial class, it became difficult to me to wake up. right? I will try my level best. I will try. So I used to teach at 6 o'clock. I used to teach at 6 o'clock. So now I want to start again with 6 o'clock. But very soon, mostly I will do at 6 o'clock also. Very soon I will start with 6 o'clock also. Right. Very soon I will start. Yeah, let's go ahead. Let's go ahead here. I like 6 o'clock classes morning like anything. 6 o'clock morning is I like anything. So that is the reason I kept. Anyhow, please go ahead this. Question number 42. Let z comma star be an algebraic structure where z is the set of integers and the operation star is defined by n star m is equal to max of n comma m. Which of the following statements are true for z comma star? Let z comma star be an algebraic structure where z is the set of integers and the operation star is defined by n star m is equal to max of n comma m. Which of the following statements are true? Remember, this is the operation. Remember, this is the operation. Remember, this is the operation. N star m is equal to max of n comma m. So remember anything, remember anyone, z comma star satisfies closure property, z comma star satisfy closure property, then it is called as algebraic structure. Next one, z comma star satisfy associative property. What does it mean? Semi group. Associative property means semi group. Z comma star satisfies identity property. Then it is called monoid. Z comma star satisfy inverse property. Inverse property, then it is called group. Z comma star satisfy commutative property, then it is called abelian group. You know this very well. Z comma star satisfy closure property, then it is called closure property, then it is called algebraic structure. Z comma star satisfies associative property semi group. Z comma star satisfy identity property monoid. Z comma star satisfy inverse property group. Z comma star satisfy commutative property, then abelian group. Someone is saying explain 42. Yeah, that's what I am doing, right? So these are the things. If anyone don't know, please refer the notes. First. It is a group theory. This is from group theory. If anyone don't know, please go and see one time. Right? I cannot explain these all the things in the class notes. We are already done. Please go and see the notes one time. Now remember, n star m is max of n comma m. Z is going to be, I think everyone knows, set of integers. So can you help closure property is satisfied or not? Of course, because the answer whichever, see, whatever you take, the answer will come max of that. So whatever you take from them only answer will come. So closure property is satisfied. So it is algebraic structure. Closure property satisfied means algebraic structure. Right? That is okay. Next one. Is associative property satisfied or not? Let me check. Let me check. See this one? Let me check here. 5, listen everyone, associative property. 5 to 9. So when you see the associative property, 5 to 9, 5 to 9. So take max of these two, 5. Max of these two, 9. In the similar way, take max of these two, 9. Take max of these two, 9. So that is the meaning of associative property, because answer is max of. Associative property satisfied. Any 3 people you take, at the end max only will come. Any 3 people you take, at the end max only will come. Associative property means association, means neighbors comparing. Will you take the neighbor 5 2? Will you take the neighbor 2 9? Take the 5 2, with that answer do 5 9. Take 2 9, with that answer do 5 9. So I think in my opinion, associative property satisfied. It is a semi-group. Z comma star. Z comma star. Z comma star is semi-group. Till now it is a semi-group. Z comma star is a semi-group. Closure property satisfied, because the result will come. If you take n star m, result will come either n or m. Closure property satisfied. Associative property also satisfied. Any 3 people, at the end max only will come. Right, that is also true. So next, let's go to identity element. Let's go to identity. Right, after completion of the associative property, let's go to identity. What is the meaning of identity element? What is the meaning of identity element is, suppose if anyone say E is identity element. Suppose if anyone say E is identity element, see this one. For all A belongs to Z. For all A belongs to Z, A star E is equal to A, or E star A is equal to A. That is called identity element. If anyone say E is identity element, for all A belongs to Z, A star E is equal to A, E star into, right, E star A is equal to A. Anyone with star operation with E, answer is anyone only. If you can find out any person like this, then I can say identity element also exists. Can anyone help me which element it is? But remember, it is not a multiplication. Operation is max operation. A star E, whoever maximum it will come. E star A, whoever maximum E will come. Can you say one element? Can you say one element? That element star anything is that element only. Can you say any element, right, from the Z, any element into E becomes any element. So what is the answer? A star E is equal to A, E star A is equal to A. But remember, star means not multiplication. Star means a max. Be careful with max. And one more thing is, Z is a set of integers. Negative integers also, positive integers also. Negative integers also, positive integers also. If you take the negative number, into E, if you take the negative number into E, assume that E is 0, then 0 will come. Because 0 is maximum. But I don't want 0, I want the A only. A comma E is equal to, if I do max, A only should come. A comma E is equal to, I want A only. E comma A is equal to, I want A only. Someone is saying that minus infinite. You want a minus infinite, minus undefined, na? You have to say some fixed number by yeah. You cannot say plus infinite, you cannot say minus infinite. That means undefined. That means not possible. Some fixed number you have to say. You cannot say minus infinite. That means undefined. Fine. Whatever you are saying true, that means undefined. You have to say some specific number. You cannot say minus infinite, you cannot say plus infinite. It means undefined. Undefined. So I think what is the answer? Z comma star don't have identity element. It don't have identity element. Identity element not exist. If identity element is not exist, there is no point of going further. So what is the answer? Answer is Z comma star is semi group. Identity pass, then it is going to be monoid. Inverse also satisfied, then it is called as group. Commutative also satisfied, then abelian group. So I think identity itself will fail. You can stop it. You can stop it. So answer is D, none of the above. Answer is D, none of the above. You have to say specific number. You cannot say minus infinite. You cannot say plus infinite. That means undefined. That means undefined. Please careful. So let's move to the next problem. 42 over. Go to the 43. Yeah, can you try this one? It is also from group theory. It is also from group theory. Graph theory will give two questions. Read the total class nodes. Read the total class nodes followed by PYQs followed by RIC. Enough. Read the total class nodes followed by PYQs followed by RIC. They are more than enough. They are more than enough. Yeah, question number 43. For the composition table, there is some table there. Is it visible? Table visible? Table visible? Operator is star. Operator star. So there is some table there. Is it visible? Yeah, it's visible. So let's start. Let's start table. So can you help me? This is already, you no need to verify. You no need to verify. Is it a group or not? He already mentioned cycle, right? Cycle group, cyclic group. He already mentioned. You no need to verify it is a group or not. He already verified. For the composition table of a cyclic group, it is a cyclic group. It is already group. So what is the meaning of cyclic group? Cyclic group means some generator is available. Using one element, you can generate all the people. Then I can say that it is a cyclic group. If you find out in any group generator is available, then it is called cyclic group. Right? In the group, using one element, I can generate all the people. Then it is called generator. A group with generator is known as cyclic group. You read the total group theory one time. One time you read. One time you read. Right? One time you read the total group theory. One time you read. Yeah, I think it's already mentioned. It's a cyclic group. So can you help me? Listen, can you help me now? See this one. Can you help me now? A star A is equal to A. A star B is equal to B. A star C is equal to C. A star D is equal to D. What is the meaning? What is the meaning? With A star operator with anyone only coming. A star operator with anyone only coming. So I can say that is the identity element. It is an identity element. A star with anyone only coming. So is the identity element. Is the identity element, everyone knows. So identity element E is equal to A. Okay, that is fine. That is identity element. I am absolutely okay. I am absolutely okay. Next one. See this one. Next one, everyone. Everyone listen. If anyone don't know, catch this point also. If anyone don't know, catch this point also. Listen. Identity element is already confirmed A. Then what you do is, in every row, A underline. 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 So what you do is, listen everyone now. D, you are already a circle, right? So to that circle, row also, column also, draw the line. So remember everyone, D inverse is C. Because their both operation is giving A. In the similar way, B inverse is B. Next one, C inverse is D. Next one, A inverse is A. After finding identity element, in every row, identity element circle. In every row, identity element circle. To get the identity element in every row, what are the elements you done the operation? Right? They are going to be inverse. They are going to be inverse. So B into B is A. Identity element is coming. So B inverse is B. C into D is A. C inverse D. Right? Next one. D into C. Right? D into C, right, is going to be A. Right? Everyone fine? Inverse also perfect. Right? So inverse, every person inverse also you know. Now we really don't want that because he is asking generators only. We really don't want. I am doing one small work. Can you see one time? Can you see one time? Everyone listen. Can you see one time? One small work I am doing. Can you see one time? Can you help me now? C power 1. C power 1 is C. Can you help me now? What about C square? C square means C into C. What is C into C? C power 1 is C. Okay. C square means C into C. What is the C into C? C row, C column check. C into C is B. That is also okay. Can you see what is the C cube? C cube is C square into C. C square is already B. B into C. What is the B into C? What is the B into C? D. Next one, that is also okay. What about C power 4? C power 4 is C square. C square is already B. B into B. What is the B into B? A. So do you believe or not? Listen, C power 1 is C coming. C square is B coming. C cube is D coming. C power 4 is A coming. Means using powers of C, I am able to generate everyone. Using powers of C, I am able to generate everyone. So C is a generator. If C is a generator, C inverse also generator. C inverse is D. So if C is a generator, C inverse also generator. C inverse also generator. C inverse is D. It is also generator. So I think C and D are generators. If C is a generator, C and D also generators. Which of the following choices are correct? Who are the generators he is asking. Generator means if I say I am generator, powers of me will generate all the people. Powers of me will generate all the people. So if I take the C, right, you can check like that A also, B also. If you want, you can verify other people also. Right? Sir, why don't you check for A and B? You can verify. You can verify. Right? You may not get all the people. Somewhere you will stuck. Same persons are keep on repeating. Yeah, perfect. C and D are generators. So I am moving to the next one. If anyone don't know generators, please read the group theory one time. Please read group theory one time. Please read group theory one time. Yeah, go to the next one. 44. So 43 is going to be answer C. Go to the 44. The proposition PR negation PRQ is. So I think everyone know if P true, it doesn't matter what it is. If P is not true, anyhow it will be true. I think it is always true. Tautology. Someone is saying how to find out inverse. Someone is asking how to find out inverse. Now see this one. After finding identity element, listen. After finding identity element, now see. Let us assume that identity element is E. Let us assume identity element is E. If identity element is E, how to find out inverse is like this one. Let us assume that two people A star B is equal to E. That means A inverse is B. Or B inverse is A. Careful. A star B is equal to E. Then A inverse is B or B inverse is A. First find the identity element. After finding identity element, two people, if you do operation, you got E. Someone is saying that maybe different also there, right? Maybe different also there. So two people, if you do operation, you got identity element. Indication that they are inverse to each other. Two people, you do operation, you got identity element. They are inverse to each other. Right? Fine, anyhow, you have to see the group theory. I cannot say everything here. Right? So let's go to next. Go to the question number 44. The proposition PR negation PRQ. I think see this one. If P true, if it is true, it doesn't matter. So suppose it is false, then it will be true anyhow because there is a negation P. So it's always true. So it is a tautology. Always true. It is a tautology. It's a very small one. Yeah, you have to revise. RIC for after revision is over. It will be useful. First to revise and come. Revise and PYQs complete. Then see this. You will get more clarity. Go to the question number 45. Yeah, can you try question number 45? Let P and Q two propositions. Consider the following two formulae in propositional logic. There are two statements are given. Which one of the following choices are correct? Which one of the following choices are correct? Let P and Q be two propositions. Consider the following two formulae in propositional logic. S1 is given, S2 is given. Which of the following choices are correct? So I think you know very well how to verify. How to verify these are statements are valid or invalid, you know very well. So, right, so some people are asking, sir, what is the meaning of, right, what is the meaning of, consider the following two formulas, right, what is the meaning of valid? So valid means this one, this will be a tautology. Valid means this should be a tautology or not, we have to verify. But if you want to say this is a tautology, it is the implication operator, it is the implication operator. If you want to prove this is a tautology, implication operator, tautology. See this one, true, 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 false, 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 true, true, false, false, true. So if you want to show implication table is tautology, this combination not arrive. This combination you have to close, then only you will get the total as a tautology. Then only you will get the total as tautology. That means TF combination we have to avoid. TF combination we have to avoid. Sir, how to prove it? How TF combination we have to avoid? How to prove it? Very simple. Very simple. Negation P and PRQ implies Q. If you want to prove TF combination not allowed, then what you do is assume left true, prove right also true. That is the one choice. Assume left true, assume, it is an assumption. Assume left true, by assuming left true, prove right true. By assuming left as true, right, assume by assuming left as true, prove right as true. Right, fine, that is the one thing. One more thing is assume left is false. Sorry, assume right is false. Assume right is false, then prove that left also false. That is the one more case. If you assume right is false, prove left false. If you assume left true, prove right as true. These are the two possibilities. Everyone know, I will try whichever model you like. I am trying the first model. If you want to prove implication is a tautology, by assuming left as true, prove right as true, or by assuming right as false, prove left as false. So I am going to do now. One time you can see. So S1 I am trying. Negation P and PRQ. Right, so I want to prove the S1. See how I am proving. Assume left as true. Can you help if you assume this as true, end operator this as true, if you assume it should be true, it should also be true. It is true means, right, negation P true means P is false. P is false if you keep R operator, P false means Q should be true. So this is the conclusion what you got by assuming left as true. If you assume left as true, these are the conclusions what you got. P false, Q true. Right? This one you go right side and you substitute. Right side you have only Q. So Q is true. Of course it is true. By assuming left true, I proved that right as true. Right is Q there, which is the Q is true. So I think S1 is a true statement. By assuming left as a true, I proved that right also true. Implication right Q there, I already proved that by assuming left as true, I got the conclusion that Q is true, which is the right hand side. So S1 is perfect. Let's go to S2. Let me write the S2 once. Q goes to negation P and PRQ. This is the S2. Let me try S2 in the similar way. S2 in the similar way, let me try. I am trying S2 in the similar way. Let us assume left side is true. Left side true means Q is true. If Q is true, by using the left side information Q as true, can I prove right as true or not? Let me check. If Q true, let us assume that Q true. If Q true, this total becomes true. If Q is true, this total becomes true. Because it's OR operator. This is true. But remember, it's a AND operation. It is a AND operation. AND operation is both should be true. AND operation is both should be true. Already, right? This part is true. If to prove that right as true, right, AND operation, left, right, both should be true. It should also be true. It should also be true. But from the left hand side, I didn't get any conclusion. What should be P? P may be true, P may be false. Left side person not given any conclusion. Left side person said that Q should be true. Yes, I took. But to prove total right as true, I should prove that this also true. So left side person not given any confirmation about P. So anything can happen. If at all P true, right? If at all P true, negation P becomes false. If P true, it will become false. If P is false, it became true. So anything can happen. From left, I cannot conclude right. So S2 fail. By assuming left as true, I am unable to prove right as true, because right is proof. Right, if I want to prove, I have to decide P. I think left person not given any information about P. So P having two choices, it may fail, it may pass. Dilemma there means it is not valid. Left person said only one thing, Q is true. With that conclusion, right, with that information, I went to the right side. That information is not enough. You have to say something about P also. Unfortunately, different values of P, it is failing. Sometimes passing, sometimes failing. So S1 is valid, S2 is not valid. We done so many problems in the classroom about the validity. So many problems we done in the classroom. Please check. S1 is a tautology, but S2 is not a tautology. S1 is a tautology, but S2 is not a tautology. So answer is B. Go to the question number 46. Go to the question number 46. Can you try this? Go to the question number 46. Can you try this? Yeah, can you go to 46? Choose the correct choice, yes, regarding the following propositional logic assertion. P and Q implies R, implies P and Q, implies Q and R. So I think there are two parts are there. This is the one part, this is the one part. If you want to prove it is a tautology, if you want to prove tautology, right, same model you have to do like in the previous one. Same model you have to do like in the previous one. So remember, right, the antecedent of S is logically equal to the consequent of S. Remember, this is called antecedent. This is called consequence. Consequence means conclusion. The antecedent of S is logically equal to the consequent of S. So let's do a similar way. Worst case you can go to that truth table. Worst case you can go to the truth table. Worst case. Worst case you can go to the truth table. Worst case. I think because of only 3 people are there, PQR, only 3 people are there, you can go to truth table also. You can go to truth table also. It is up to you. Because of small expression, you can go PQR, 8 combinations are there. You can try like that also. Left side you check, right side you check. So how you are going to do? Truth table or using the normal process and all? All are true, then tautology. All are false, then contradiction. So I think instead of thinking that much, you can go to the truth table also. There is nothing in that. PQR, only 3 people. Let's see this only for namesake. PQR. It will take few minutes only, so that is the reason I went here. No need to think that much. Now can you help me? Can you help me now? I think common thing is P and Q. What is the P and Q? P and Q are Q and R. It's going to be P and Q implies Q and R. It will take 1 or 2 minutes, but finish it off. There may be many ways, no need to think much, right? You can go ahead. Start now. So P and Q only start. P and Q. True, false, false, true. P and Q only. True, false, false, true. What about here? P and Q. False, 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 false. Go to the next one now. P and Q employees are. P and Q employees are. So what is the answer? So P and Q employees are. True, 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 false. True, 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 true. Go to the next one now. Q employees are. Q employees are. Q employees are. True, 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 false. Q employees are. True, false, true, true. Next one. P and Q implies Q and R. I think this one, this one, this one, this one. True, 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 false, right? False. Check properly. Next one. True, 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 true. Now you compare, you will get the answer. Is it say this table say? Verify. TT, TF. Yeah, both are equal, right? equal people, listen, equal people, if you do also, if you do the employees equal people, if you do employees, right, you will get the tautology. It is a tautology. The antecedent of S is logically equivalent to consequent of S. Is it fine? Yeah, so see the table. Just write down the table. I am not done anything. Just write down the table. This is assume that 1, this is assume that 2. You always remember, two equal people, if I do employees, right, it will be tautology. Two equal people, if you do employees, it is a tautology. See this, true, because a TF combination not allowed. TT, true. Next one, TT, so true. Two equal people, if you do employees, right, it is a tautology. Just draw, I am not done anything, right? I just, whatever space available, I managed it. Only one expression, if you want to prove tautology, you can go to table also. If many expressions are there, like previous method you can do. Previous is very simple, tautology or not, but here some more things are there. Logically equivalent and all. So I don't want to take risk. I went for table. Previously only one thing, tautology or not. If the question is only tautology or not, do like this. If the question is like tautology or not, do like this. If the question is something like something else, see this one. Here tautology also there, and some more thing. They are logically equivalent or not. See the option D, logically equivalent and all. So I thought, let's go for a table. I can prove tautology or not, but I cannot say D option. So D option purpose I went for table. Tautology means you can do the previous approach. Only tautology, previous approach is enough. But he is saying that left, right both are equal or not. Left, right both are equal or not. So that is the reason I went for a table also. Two equal people, if you do employees, you will get tautology. So two people equal means it is actually double employees. Two people equal means it is actually double employees. Two people who are equal, 1 and 2 equal, that means 1 employee is 2, right? 2 employees 1 also. Equal people you do employees, you will get tautology. Because you never see TF. When you say equal, both are equal. Left true means right also true. Left false means right also false. Where will you see TF combination? TF combination you never see. You never see TF combination. Left T, right also T. Left false, right also false. So TF combination you don't see. If you don't see TF combination, you never see in the implication table false. So it is a tautology. Can I move to next problem? Check next problem. Can I move to next problem? Check. 46 over. Can I go to 47? 46 nothing, table. 45 is standard procedure to verify tautology or not. Implication tautology or not. See this one. Implication tautology or not. It is a standard procedure. But if more asking, something like equal, something like that, then I think maybe something extra I have to do. So I think it's a 46, it's a 45. I think a swap maybe should be done. So anyhow. So can you go through it? What is the answer? So remember, listen. In the 45 question number, if you see, it is a double implication. Double implication means both are equal. Double implication means both are equal. You remember, right? If anyone don't know, remember, A double implies B means, that means both are equal. A double implies B means both are equal. A implies B, I cannot say A is equal to B. A double implies B, then both are equal. So someone is saying D, B. Let's see. B also, D also. Right? It is a, I think maybe, right? It is a MSQ question maybe. MSQ question maybe, right? Two are the correct. They may ask you which are wrong, which are right. How many statements are true, how many statements are false. But anyhow, come back here. Remember, A double implies B means A is equal to B. But remember, A implies B, single employee. Right? It doesn't mean that A is equal to B. It doesn't mean. Single employee, I cannot give guarantee. Double employees, I can give guarantee. A double implies B means A is equal to B. A single implies B, I cannot say that. This one I cannot say. But this I can say. But if someone say A implies B, I cannot say A is equal to B. But someone say A double implies B, I can say A is equal to B. Yeah, now see, they given something. Assume that the equivalences, these are valid. Then the truth value of the formula is something like that is given. Right, now see. There may be many ways. I'm just doing one thing. See this, see everyone. A and B implies A and C are D. It is a given one. It is a given one. So if you want, I will keep bracket also. Assume that this bracket is there. Assume that this bracket is there. Okay, fine. So this can be written as, right? There may be many ways. Then the truth value of the formula is, if you want, you can take the once again, table you can take. I don't have any problem. You can take a table also, no problem. Right? So this is the one. So this is nothing but, listen, this is nothing but A and B implies A and, everyone know B and C both are same. A and B are D. So I everyone know C means equal to B. C and B both are equal. And one more thing I want to say to you, listen, if these two are same, can you help me now? If B true, negation B is false. So this is always true. This is always true means A also true. A always true. Right is always true means left also always true. Right? I hope everyone fine. And one more thing, see this one more thing. In the implication table, left side, right side same. Compulsory always true. In the implication table, left side, right side always true. Left side, right side same means it is always same. True or D. So finally, it is true. In the implication table, left side, right side same. A goes to A, always true. A goes to A, always true. Fine then. If B is false, then negation be true. If B false, negation be true. So finally overall true will come now. See anything I done wrong. Otherwise, see, very simple. Just go to the truth table. Just go to the truth table. But remember in the truth table, right? Remember, C is nothing but B. C is nothing but B. A is always true. C is nothing but right? C is nothing but B. Always A is true. Always A is true. Just go to the truth table. So this table, right? If you want, you can go to the table also. See this one. A means true. True and B implies true and B are D. Right? They kept bracket. So you also, if you want, you can keep bracket. Just go to the table. Nothing there. True and B means, I think left side B. True and operator B. B implies true and B. True and B. So B. True and B. So B. B or D. B or D. Check if I done anything true, anything wrong. See, if the B true, this also true. If it is false, it doesn't matter. Whatever it is, no problem. So there is no question of true false. So this is always equal. So answer is what? Tautology is always true. See, TF combination not possible. TF combination no chance. TF combination no chance. See, so from the given expression I can say A is true. From the given information, I can say C is B. So true and B becomes B. True and B becomes B followed by D. So if B true, right? So left true, right also true. If left false, right can be anything. Because it is anyhow true, it is anyhow true. So tautology. Sir, how to verify option C? What is the option C? Same as the truth table of B. Same as the truth table of B. Then the truth values of the formula A and B is always so you can just draw the table and you can check one time, right? Draw the table, you will get the clarity. See, the only thing what you can do is use the given information, draw the table. Because of so many options are there, right? With the given information, draw the table, you will get the clarity. So always this result is equal to always B or not verify. This result is equal to always D or not verify. Right? Diksha, just draw the table, nothing there. Just draw the table. Yeah, you have to go to table. Just draw the table, verify. Final result is equal to B or not. Final result is equal to D or not, verify. Yeah, both the things you verify. Fine, can we move to next problem? See, this information use. The only thing what you can do is this information use. Remaining thing you substitute. So this is the given equation, right? A and B, A and C are D. This is the given information. A and B, A and C are D. This is the given information. This is the given information. Simplify as much as you can. Right? So as the problem is mentioned, it is a true. True and B. Right? This is going to be A and C. It will also become A and B or D. This will become B employees. Right? A becomes true means B or D. So finally this is going to be B goes to B or D. Finally this will goes to B or D. So for this one draw the truth table. So B and D only there. Let me write B, D, B, right? Next one B or D. B goes to B or D. Right? So just verify all the things. It's going to be true, false, true, false. right? So BRD, what is the answer? True only. Anyone? True, it is a false. Now go here. Now BRD. So what is the answer? This true true. So it is a tautology. We already proved that it is a tautology. Right? Now verify the other options also. Only one expression given means they may ask more options. Right? This is the case. Now check. Final result and B same or not? Final result and B same or not? It's not same. Final result came all true. But B, if you see, true, false. Final result, if you see, all true. If you see the D, TF. Right? Thank you Diksha for asking. So answer is going to be true. Same as the truth table of B, I cannot give guarantee. Same as the truth table of D, I cannot give guarantee. See, whenever one expression only given, they will ask more options. Please take care. It's a nice problem. GATE exam problems will be like this only. The only conclusion I can say is A is equal, right? From this I can say B is equal to C. From this I can say, right, A is true. This is the only conclusions what can I give. Those values you substitute in this. Right? You will get the finally truth. So I think this is also not required. You can go this. This is the final conclusion. So T and B are D. Right? Remember, brackets are there. T and B becomes left side B. T and B becomes right side B RD. So it will goes to B BRD. Right? So it is a tautology confirmed. Because of Diksha asked me some other information. What about B table? What about D table? What about the final result? So I done the table for this. Right? What really required, draw the table, because table may consume 1 or 2 minutes. Remember, it is a very nice problem. It is a really nice problem, right? If anyone is not getting, one more time you check. Nothing there. So this one unnecessary part which I feel, it is unnecessary. That is also correct, but it is unnecessary. Make the things easy. So this is the final conclusion. So it is a finally tautology. Because the TF combination not there, so tautology. So next one. What about B table? What about D table and all? I given the table also. Please take care. It is a really nice problem. Right? Go through it one more time. Yeah, next problem. What is the next one? Yeah, 46. Yeah, you take care of this problem. If we conclude final value of expression always true, then it cannot be same as truth table of B or D. Yeah, we cannot conclude, right? Yeah, someone is saying, see, finally all true coming, that is the reason true. But I cannot say B table is equal to final result. I cannot say D table is equal to final result. I cannot say that. Right? Fine. All true coming, see. Final result is all true coming. But B table and final one, if you result, see, if you see the problem, what is saying? Is always same as the truth table of B. Is always same as the truth table of D. Right? No. See this one, finally true, okay, but B value false, then also final result is true. D value false, then also final result is true. Yeah, fine, perfect. Let's go to this problem. 46. 46. Let PQR denote the statements. It is raining, it is cold, and it is pleasant, respectively. Then the statement, it is not raining, and it is pleasant, and it is not pleasant only. It is so something is given. Can you read it and start? A implies B. A implies B is a tautology. A implies B is a tautology. It doesn't mean that A is equal to A implies B. A implies B is a tautology. It doesn't mean that A implies B is equal to B. So be careful. If A double implies B is equal to tautology, then definitely they both are equal. Yeah, concentrate here. P is it is raining. P is it is raining. It is cold. Q. It is pleasant. It is R. Then the statement, it is not raining, and it is pleasant, and it is not pleasant only if it is raining and it is cold. See, almost everything is similar pattern. Everything is similar pattern. Is there everything similar pattern? You can easily do this, I think. So I want answer from you. P implies Q. Different ways of writing. P implies Q. Can you help me now? Can I write P implies Q? P if Q. P implies Q. Can I write P if Q? P implies Q. Can I write as P if Q? Which one is right? P if Q. If P, then Q. Which is correct? P implies Q. If P, then Q. P if Q. Which one is correct? Q if P. Which one is correct? 1, 2, 3. Can you help me now? Which are correct? In your notes already there. P implies Q. 1, 2, 3. Which is correct? P implies Q. 1, 2, 3. Which is correct? P implies Q. If P, then Q. Q if P. I think everyone know 1, 3 correct. 1, 3 correct. I am writing fourth one also. Can you see this one? I am writing fourth one also. Listen, I am writing fourth one also. P implies Q can be written another way also. P only if Q. This is also correct, remember. 1 correct, 2 correct. Sorry, 1 correct, 1 correct, 3 correct, 4th also correct. Only if there, it is correct. Only if there, you can see notes. If P, then Q, that is one way. Q if P, that is also okay. P only if Q. Only if are there. If only their problem. If right, if at all, if anyone say no, these two are not same. See, only if P only if Q. So 2 is not correct. Remaining are correct. remaining are correct. So remember why I said this one, you will get to know. See this one, only if it is not raining and it is pleasant. It is not raining and it is pleasant. So raining is going to be P, not raining means negation P. And it is pleasant. It is pleasant means R. Negation P and R. And here game is actual game is here only. And it is not pleasant, and it is not pleasant only if. End means end. And it is not pleasant, and is there. See this one. This is the only trick he played here. It is not pleasant only if the raining it is cold. This is the game where he played. And it is not the pleasant. Pleasant is R. It is not pleasant means, right, negation R, right? Only if means implies it is raining and cold. So he done the reverse. This is the only mistake what you can do. Remember, P implies Q means, right? P only if Q. This is the only game what he played. And it is not pleasant means negation R. Only if means implies it is raining and it is cold. This problem is based on this line. Do you know this line or not? If anyone don't know, so okay, if Q, they will do reverse. Q goes to P, then option B. Are you getting? So answer is option A. If you do ulta, Rohit, if you do ulta, then answer become B. P implies Q means P only if Q. See, these two are gone long time back. The only confusion is AB. But remember, if you know this line, P implies Q means P only if Q. Because of that line, this also gone. This problem is based on this information. Fine, can we move to next problem? So from this problem, please can you remember? P implies Q. So many ways of writing. Please see the class notes one time. I cannot say all the things here. If I keep on saying one problem only, I can say. Just from this problem, you remember one thing. P implies Q. If P, then Q. Okay. Right? So P, if Q is wrong. P only if Q, it is right. P implies Q means if P then Q true, right? So this also right, if P then Q, right? That is already done. Next one more thing is Q if P, this is also true. P if Q is wrong, Q if P is right, but the same thing you can write, right? Only if you keep, you can write only if. Lot of debate happened in the classroom at this statement. Lot of debate happened. Right, in the classroom at this line, lot of debate happened. I still remember Rohit done dharna. Whenever this statement is going on, Rohit done dharna. I still remembered. He done the dharna. How can you write? He done dharna. This line created lot of nonsense in the class. He done dharna. I still remember he done dharna. I said, why are you doing here? He said to me, I hate you. I said, same to you. Whenever this line is going on, Rohit said, I hate you. Yeah, fine, perfect. This problem is completely based on this line. Please take care. Q if P true, but P if Q is false, but P only if Q is true. Right. Go to the question number 49. Go to question number 49. Yeah, I think this is normal statements only. You have to prove which is valid, which is not valid. It's the standard problem. Can you go ahead? So you cannot draw the table for these many people. You cannot draw table for these many people. Valid means tautology. You have to prove tautology. Many things are given. Go to our actual story. Yeah, try one by one. Normal story. Assume left true, prove right true. Assume left true, prove right true. So what is the answer? Normal thing only. I am trying for P. I am trying for P. Negation P or Q and R goes to S and P R. Implies something he said. Negation something like that he said. So let's see. Let's assume it is true. Let's assume it is true. It is true means all should be true. You take any combination. There is no objection here. You take any combination. Any combination you can take. No objection here. No objection. Let's take any combination. I am going for negation P or Q. Negation P or Q I am going. Right? Negation P. If you want, you can try something else also. Let us assume that this one I am trying. P R. So this is going to be true, true, false, false, true. These are the combinations. Right? So remember P true, right? P true, Q R, right? P R Q, P R R, true, false, false, true. Those things you substitute in the remaining part. Remember P R. Right, P R, so see some P true, R true. Substitute P true, R also true. substitute. First combination I am trying. P true, R true also try. Then it became false. Then conclusion is Q should be true. Right? I am substituting this combination. P true, R true. P true, R true, I am substituting. R true, P also true, I substituted. Then negation P becomes false. False or Q becomes Q. Q should be true. And one more. Right? So, listen, R goes to S. R is already true. So, this should be true means S should be true. So, final conclusion. Right? So, here how many people are there? P, Q, R, S. Totally 4 people. So, P true, R true, S true, Q true. Take these 4 values, you substitute on the right side. For this conclusion, right side is true or not, verify. What are the things? All 4 people true. Let's check. Right also true or not, verify. So if it is true, negation true becomes false. But this is already true. Right? So false implies to true. So finally, for first combination, all are perfect. Let's try second combination. Right? What is the answer? P true, Q, right? P true, R false. So R is false. So P true. P true means I think same. Q true will become, right? R is false. See the answer. R is false. S should be true or false. Anything is, right? S may be true or S may be false. It doesn't matter. So in the second combination, P true, R false, Q true, S may be true, S may be false. Right? You substitute. Right? So, but Q is true. So, because of that reason, anyhow true. S doesn't matter. S is true or false doesn't matter because Q is already true. So, second combination also it is true. Go to the third combination. Third combination was false true. So, P is false. If the P false means negation P become true. True or anything. So Q can be anything. Q may be true or Q may be false. It doesn't matter. If the P true, if the P false, negation P become true, true or Q becomes. What is the answer? True or, right? So true or Q becomes anything. So Q may be true, Q may be false, doesn't matter. But what about this one? R is true means, S should be true. So finally substitute. All the information you substitute. Q may be anything. S should be true. I think true. S should be true. S is true means negation true becomes false. False and anything false. I think there is no problem at all. Right? Fine. I hope everyone is fine now. Like that you can check, and one more, some rules also there. You know, in the class, whenever class is going on, I verified some rules also. Some rules I said, you can apply those rules, right? Those shortcuts also you can apply. In the classroom I explained already. Right? Here, I think 3 combinations you have to cover. Nothing much, right? There is nothing much here. 3 combinations you have to cover. PRR, which contain 3 combinations. Just try 3 combinations. It may be time consuming. This is the one way. One more way is shortcut is there in your notes. I already said so many formulas to you. You can apply one by one formula. So finally P is true. Right? In the classroom we are already done. See, worst case what can happen is, right? You have to try 3 or 4 combinations. 3 or 4 combinations you have to do, and one more way is in the class notes I said some shortcuts. You can apply those shortcuts also. Some people may not remember those shortcuts, so I done manually. Right? Fine, that's okay. So finally P true, please take care. Now go to the Q now. I think because of your end operation is there, it may be going to be easy, right? Let's check. Negation P and Q Q implies P implies R. Right, so this is true. This is true. This is true means, right? This is true means, right? Let me write now. True, true. False, true. False, false. So, right, first combination you try. Negation P true means P false. Right, in the first combination, Q true. So, this is already true. This is true. It cannot be false. Whatever it may be the R. Whatever it may be the R. Because false followed by true or false anything. This combination again check. This combination again check. So in the first combination, negation P true means P false. P false. Right? P false. What is the Q? Q true. What about R? R may be true or false. It doesn't matter. Check on the right side. Check on the right side. He is saying that negation R should be true. It doesn't matter. So Q fail. Q fail. Right? Go to the R now. So I think first combination only we completed. So Q cannot be true. Go to the R now. Right? Go to the R now. Again same story. Q and R. There are shortcuts are there. Class see the class notes. You can apply those. RP and is implies R is saying, right? Similar way you go here. Similar way you can go here. So true, true. So it's I think it's an AND operator, right? Fine. So let me go one by one now. R operator. What is the answer? True, true. True, false. False, true. So like that you keep on verifying. So what is the answer here? What is the answer here? If you apply formulas, right, these will be going to be very easy. Apply formulas, these are going to be very easy. In class notes, whatever formulas are there, you apply them. Right, if I say now, some people may not know, some people may be forgotten, revise the notes one time. Right, worst case you can do like this, one by one combination you can check. So I think can help you now. Negation Q, RP, true, 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 false, false, true. Negation Q, first let's see the first combination. Negation Q true means Q false. I want this as true. So what is the P? P true. So R may be anything. R may be anything because right implication operator, right is already true. So it never be false. I think R can be anything. R can be anything. But he is saying that R should be true. He is saying R should be true. Need not be. R should be true. He is saying need not be. So Q cannot be. R cannot be. Right? I think someone is saying C. I think that is the only answer. Right? Please check properly. Nothing. So it look like lot of combinations. If you lucky, one combination enough. See. First one, many combinations I tried. But because the true will take some time. To prove something true, it will take some time. To say false, one incident enough. See, here itself false. Here also, one incident only enough. But the P taken some time. All combinations I tried. Right? Let's go to, if you want, you can go for S also. Only for namesake S I am doing. Only for namesake S I am doing. P and P employees are. P and P employees are. And Q R negation R. Right? So let's see. Is P true? P true. This is also true. So R should be true. So P, I think now everything is fixed now. R is already true. R is already true. So if it is already true, it can be anything. Sorry for this one, right? R is true, right? R is true. R is true means negation R is false. So Q should be true. Q should be true. That's what he is saying. Q should be true. Right? I think you can apply those formulas. If anyone is forgetting the formulas, you can apply manually also. Answer is PS. In the classroom, many problems we done, only for namesake I given. I want to say to you, please remember all the formulas, whatever we covered in the classroom. Nothing much, nothing new here. Nothing new here. So answer is going to be PS true. Some became right, some became easy, some became little time consuming, but still you can do it. Still you can do it. Some are time consuming, some became very easy. I think last one became very easy, second one became very easy, third one also became very easy, because one combination you can prove it. One combination you can prove it. Right? One combination you can prove. Only first one taken some time. That will also take less time if you apply formulas. If you apply formulas, that will also take less time. So I think P true, S true. So answer is C. Yeah, perfect. What is the next one? 50. What is the answer of this check? What is the answer of this? Consider the following statements. Good mobile phones are not cheap. Cheap mobile phones are not good. P implies Q. Q implies P. P is equivalent to Q. Which of the following about LM and are true? Yeah, let me ask you one small line. Good mobile phones are not cheap. So remember, for not don't give any name, right? See this one. Good mobile phones. Good mobile phones. Assume that good mobile phones. Assume that, right? Some name I want to give to you. Good mobile phones are not cheap. Cheap mobile phones are not good. Good mobile phones are not cheap. Good mobile phones. Let me give some name. He is saying something, that's fine. Let me give some name. P implies Q. P implies Q, Q implies P, P equivalent to Q. So can you help me? Good mobile phones are not cheap. That is P. Can we divide P further? Can we divide P further? Yeah, so divide further. Good mobile phones, G, right, are not good, right? Cheap mobile phone, C. So right, what the P saying is If it is a good mobile phone, it is not cheap. So what the Q saying is, cheap mobile phones are not good. Cheap mobile phones, C. Good, right? Good mobile phones is G. So cheap mobile phone C goes to negation G. Right? That is the one. I think everyone fine till now. Everyone fine till now. Can you help me? Can you help me one small one? These are the two statements, okay. But one thing I want to ask you, for this one, what is the inverse? Inverse is, listen everyone now. Inverse is going to be negation C G. You done the inverse, again do complementation, right? It will become C implies G. Can anyone help? These two are equal or not? These two are equal. First to do inverse, then do negation. Can you help? What is the name of this? In the class notes we written the name also. First to do inverse, do negation. Can you say what is the name of this? If anyone remember, what is the name of this? Do inverse first. Do inverse first, then do negation. Then both are equal. Yeah, someone is mentioned contrapositive. Contrapositive. Both are equal. First to do inverse. First to do inverse, then do negation. If you do inverse, they both are not equal. First inverse. Inverse means reverse. Then do negation. Then they both are equal. So remember both are equal. P and Q both are equal. P and Q both are equal. Right? Next one. Let's see. Only is there, it is not. So P implies Q. You only say equal people. Definitely implies will work out. If at all two people are equal, A implies B also true. B implies A also true. Equal means double employee is possible. Whenever you say two people are equal, double employee is possible. P implies Q also possible. Q implies P also possible. So P is equivalent to Q. These two possible means equivalent. So answer is D. Many people said answer is D. Thank you. So it is a contrapositive. You have to read notes one time. One or two problems will trouble you. Whenever one or two problems are troubling, please go to the notes, revise one time. It is not your fault, it is not my fault. Suppose somewhere I am also troubling, I have to revise. Because of I am teaching so many subjects, right? Maybe from my cache memory, few things are going out. Maybe I have to revise again. You also have to revise because I am teaching 6 subjects. When I am teaching one subject, another subject maybe will go out of cache memory. So I have to revise again. You have to study 12 subjects. Guarantee from your cache memory also, they will go out. It's not a fault. The only thing is frequently how to visit. Frequently you have to visit. So almost like 2 months back, I taught all these things. Right? 2 months back, I taught all these things. Again for RIC, I have to revise again. Yeah, page fault because we have limited memory. You have to study 12 or 13. I have to study 6 subjects. You have to study 12 or 13 subjects. It is not a fault, just revising one time. If you revise one time, you will get it. Right? Page fault, true. So remember, page fault will happen to every person. There is no one here on this earth who don't have page fault because we have limited cache memory. Limited cache memory we have. When you are trying to keep something, something else will go out. You have 12 subjects frequently. Suppose assume that something is not there in the cache memory. Just go to that notes, revise one time. Only that topic revise. Suppose this area I am facing problem. Go to mathematical logic chapter. One time you see. One time you see. Suppose this problem troubling you. You don't know the name of this. Go to mathematical logic. One time you see. Necessary time you see. You no need to revise the total notes starting to ending. Starting to ending, you no need to revise. Whichever area you are facing difficulty, please go and revise. Whichever area you are facing difficulty, please go and revise. Right? Fine. Perfect. So remember everyone. Listen, remember everyone. Not cheap. Careful. Not cheap. Not cheap. You cannot keep the name as C. Not cheap. You cannot give the name as C. If anyone do like this, you are gone. Not cheap. You cannot give the name as C. So not cheap. Listen everyone now. Not cheap. So this is C. Not cheap means negation C. You cannot give. If anyone give not cheap as C, gone. That is a mistake which will happen. Not cheap, you cannot give the name as C. Cheap is C, not cheap is negation C. This is the only thing which you can avoid. This is the only thing which you can avoid. So, because a big sentence, I split it into two parts. If mobile phones are good mobile phones, then it is not cheap. You may say that, sir, why employees came, sir? See, same thing. If mobile phone is good, it is not cheap. If mobile phone is good, it is not cheap. Next one. If the mobile phone is cheap, then it is not good. So I think employees will come. Right? Please, whichever area troubling, revise again. Because you have 12 subjects, you have to revise most frequently. Otherwise, out of your cache memory, it will go out. Out of cache memory, it will go out. Right? Fine. Perfect. So until 50 we done. Until 50 we done. Until 50 we done. Please take care. So in the next class we will see some more. In the next class we will see some more. And one more thing is, right? If anyone having any difficult problems of discrete mathematics, you can WhatsApp me. You can WhatsApp me. In the next class I will take. If you have any difficult problem, you can WhatsApp me. If you ask suddenly, I may not be able to give answer. Maybe it will take some time. If you ask suddenly something, right? Right? It may take some time to me. Right? Because I also teaching so many subjects. If only one I could have handled. Because of many, they may be out of my cache memory. I have to revise again. I don't want to waste your time and my time also. I want to make class efficiently. If you throw randomly something, to understand problem will take some time. Maybe some data missing. I have to add some missing things. I have to make everything all right. I cannot waste all the people time. If anyone having any doubt, please send to me. I will also prepare and I will come. So I will do that. Diksha, I will see that. Right? I will see in the next class, I will see that. Right? Fine. Thank you so much. See you in the next class. Please, right? If anyone is not seen, 5 classes I done. 5 classes I done. I done 5 classes. So my suggestion is, right? These are all the problems. One time, please go through it. If anything troubling, please let me know. If anything troubling, please let me know. I done 5 classes. 5 classes of RIC I done. I am thinking 5 more will come. At least I will do 150 problems. From the next class onwards, I may try to do 20 problems. Yeah, thank you. And yeah, we can go now.